See you online. I'm sorry. Append that to the end of the one we just finished. Was that what? Video 8? I forgot to say that. I broke my own convention. So, hello. This is video 9. My mind is in the oil field. My mind is in the plots and in the deposits and all that stuff. What am I doing? I am trying to think recursively. And that's what I'll call this. Thinking recursively. I guess that means I'm thinking about thinking. Maybe. Okay, we'll just dive in with this thought in mind. If possible, let's take a local, not a global view. Well, actually keep all those 5 bullet points in mind that I put on that abstract video earlier on. Step 0. This is all set up right here. Get everything set up just the way we like it, and then dive in with our recursive algorithm. Set up step 0. And you'll recall from the last video that we are working with this oil field with ats and stars and all that stuff, and we want to find it. I'm going to start step 0 with a question. Why not go ahead, and let's be general about this so it works in a variety of cases. Why not go ahead and design the algorithm for the 3-dimensional case? Wouldn't that be cool? So it's not just X and Y, there's also Z. It's like a cube where we search through oil. Or, if you're completely general, or the N-dimensional case. Yeah, that's the ticket. And you know what would be cool? Instead of that boring XY rectangular grid, why not use polar coordinates? You know where I'm going with this? I'm not sure I do, but I think I do. ... Why not indeed? Why not do all that stuff? The answer, because that's moving the wrong direction. Because that's the wrong direction. I'll just say that. That's the wrong direction. I bet you're relieved to hear that, huh? We're not going to do that. That's the wrong direction. If possible, at least at this stage, we want to simplify the problem, not make it more difficult. We want to simplify. 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 Not complicate. If you want to do it for the 3D case or the N-dimensional case, get out there to abstract dimensions and all that, and use polar coordinates, knock yourself out. But do the basic version first. You start with that. I mean, code like this, where there's a bizarro algorithm and it's fun, you play around with it, you sort of use the V'ger model if you've ever seen the first Star Trek movie. You start with that simple little V'ger, the Voyager satellite, and then you can travel around the universe and accumulate arbitrary complexity if you want to. But that's for later in the game. First, we got to get the basic case solved, for crying out loud. And then we work on the advanced stuff. So I'm even going to X that out. No step 0 for us. What about step 1? You know what? Get off my whiteboard. I don't have room for you anymore. You are a worthless step. Be gone. So what is a legit step 1? Let's ask an alternative question. In effect, the opposite question. Is there any way to simplify the problem? Oh, and by the way, the problem, until further notice, is that oil field problem. Find oil. Let me see if I can get the terms right. Find a connected region of, I can't, it's not plots, pockets. There, I got it. Find a connected region of pockets that constitute a deposit and count that deposit, and we want to know the total number of deposits. I have an abstract grasp of the problem, the technical details in the words. I don't think I'm ever going to get that. Is there any way to simplify the problem? That's the question. Answer. In fact, yes. Yes, there is. Standard ways to simplify problems like this. There's more than one. One thing is rapidly we've observed, you probably observed, and we just didn't say anything about it. The input has only 2 characters. Specifically, and I think I do remember those, star or asterisk, star, and that sign. Things that make you say, Well, that's not a big deal. I mean, I can read in star and asterisk. It might be tricky reading in characters. We are going to have to use an input file. And for some reason, characters can be maniacal to deal with. So we could read those in as strings. I read in a string asterisk and a string @ sign, and that's not too much to deal with. Except when there are only 2 possibilities, only 2, that triggers in the computer geek's mind, well, you know what? That's binary. That's 1 and 0. So the input has only 2 characters. Why not map, or change the problem, map them to 0 and 1? Why not indeed? Now, not only can we replace, as we're reading it in, all we're doing is simplifying the problem for us internally, because we're going to be reading this into an object in a class. And if we want to change asterisk and @ sign to 0 and 1, that's our own business. Outside the object, you don't have any business even looking at how we're representing this stuff. Now, not only that, but since I don't remember, I do. I was going to say I didn't remember which is which. Look at me, I do remember. That means no oil. That means yes oil. So if we've got a clear-cut distinction between what our 2 input values mean, then we want to try to preserve that with a 0 and 1. So 0 will be no oil, 1 will be yes oil. Successful. We did find oil there. So, for example, for the fig, let me whip out my 2 colors again. I hope I'm using them consistently. I think the @ sign was oil is present. Is that right? It wasn't that color. It was red. That was rust or something. One moment, please. Well, pink. That's close to red. @ sign, then asterisk. No. Yes. Yes. That's what I want to do. I'm sorry. @ sign, asterisk, @ sign, asterisk, asterisk. What does it mean to map it? It means you keep the same information, you just transform it into a format that's easier for us to deal with programmatically inside our code. @ means yes, there is oil there. So I'll even use the same colors. 1. Oil is present, and there's a 1 over here. I'll get it while I'm here. And there's a 1 down beneath. Zeros for all the non-oils, for all the stars. Empty plots with no oil. You're not a pocket, you're just the plot. It doesn't seem like I simplified it, does it? With so much pain and suffering it took for me to just write that on the board. But look at what we got here. Inside the code, once we get busy and actually start searching for oil, we got yes or no answers, whether or not there is oil in there that we can check as if it's an integer. Well, it will be an integer value. A quick, easy test. We don't even have to put double equals in there. We can just say if grid square. And if that's true, that means that it's a 1 rather than a 0. And we know there's oil there. The alternative is to leave it in this weird format over here that's either got strings or characters, and we'll have to test individually for an @ sign or a star or whatever. So, ladies and gentlemen, I present to you that I believe that to be a legitimate and worthwhile simplification. We get to do that. We get to store the data in a format that is comfortable and easy for us to use. Or comfortabler and easier. It might still not be easy, but we'll see. What we always got to watch out for assuming that that made sense. 2, with the linked list and all the others, yikes, those pesky boundary conditions. Boundary conditions are running off the edge. Our boundary condition was running off the end of the list. We actually finessed away, and that is a term that's used occasionally, even in computer science. We finessed away the boundary condition of the empty list. How so? We said, well, we're going to put in an empty head node, and poof, the list is never empty. It almost feels like cheating, doesn't it? We start off in our constructor, put an empty head node in there. The entire purpose for that was not only to anchor the front of the list, but so we didn't have to keep testing to see if the list was empty all the time, for crying out loud. It's never empty. So, boundary conditions here, look at this. Let's say that this is our internal representation now. I'll make this stand out from the text. There. That's a region. I don't know why I can remember region and not any of those other terms, because region doesn't even matter. Maybe that's why I remember it, because it's useless. Here, when I'm going through this grid looking for oil, just look at all the boundary conditions. There's a boundary on every side. I could go too far that way. I could go too far that way. I could go too far up. I could go too far down. I'm going to have test before I can even look to see if they're oil. Every one of those, by the way, every one of those is part of the base case. Or you could even think of it as multiple base cases. I like to think of it as one base case to remember I've got to group all of that at the top. That's got to be the very first thing inside the function. And it just works better for me when I'm trying to design this to remember, you know, all that stuff that means don't call yourself anymore. That needs to be right there at the top. So these are like individual subcases of the one base case. Off the top, off the bottom, and so forth. Okay, so that leads me, let's see, this is 2. Question, how can we, and I would put finesse if I knew how to spell it. Finesse away, you can write that down. How can we get rid of, that's the clumsy way to say it, get rid of these boundary conditions? Oh, if all the problems were so simple. State a problem. Oh, this is a terrible problem. And then just write out an answer. This is how you get rid of it. Well, fortunately for us, in the world of zeros and ones and computer algorithms, often is the case. If you're clever enough, you can get rid of it. And this is my own term. I made this up. Actually, I made up these finesse away conditions here. I've used these tools before. Oh, look, there are only 2 possibilities. I'll either make it a Boolean array or integers, because integers are easier to work with. Zeros and ones, I can print them out while I'm debugging if I want to, and that's not so direct with Boolean. See how lazy I am? All of this stuff is really rooted in laziness. How do I make this easier for myself? Watch this. Put a, and this is my term, bouncy wall, B-O-U-N-C-Y wall. Bouncy wall of protective, P-R-O-T-E-C-T-I-V-E. Zeros around the region. Now, what on earth is that talking about? I'm going to start with this. I've got all these markers open. I'm going to see if I can juggle them. I'm going to start with that. That's my before picture now for my fig. Here's the fig. One, 0, 1. And then downstairs, 1, 0, 0. There. That's my original entire region where I'm going to search for oil with the ugly, weird characters finessed away. And I'm actually going to keep all that. I need that same information. I still got to search for oil, find the pockets, distinguish them from the plots. So I'm still going to have 1, 0, 1, and then the one down beneath it. I should just write and not talk so I'm not distracted. 1, 0, 1, 1, 0, 0. But now I'm going to switch colors. Watch this. Since I get to represent the data any way I want to, I want to put a collar or a bouncy wall of zeros around the whole thing. So I'm going to do this. 0, 0, 0, 0, 0. Extend one before and one after. 0, 0, and then a bottom row down here. 0, 0, 0, 0, 0, 0, 0. Look at that. It's certainly prettier. It's got more colors in it. But look what I did. I added an extra protective wall of zeros above, an extra protective wall of zeros below. On the left, solid column of zeros. On the right, solid column of zeros. And you might think, what a ridiculous thing to do. Looking ahead, our base case is going to be, oh look, I hit a square with no oil. Base case, I back out. I'll return. Look at this. Here, if I'm looking for oil, and also I'm looking at the neighborhood, the squares around me to see if they have oil, look at this. This has the potential of running off the edge two different ways. When it looks to the left, it says, okay, there's no oil, return. Then it's going to try to go up. That's where I'm going to have to be careful and test and make sure I'm not out of bounds. Can't do that. Then off to the right, offsides. No, can't do that either. So there's all kinds of stuff I'll have to check for the base case. 0 is a base case, but so is off of the top of the region. So is off to the right of the region, the left of the region. Same thing over here, that same one. I go to the left, there's no oil, base case, return. Let's look up. I go up, no oil, return. I go to the right, no oil, return. I finessed away almost all the boundary conditions. I look beneath me, no oil, return. Wah. I'm a little deposit of one plot. You have no idea how proud of myself I am right now. I got both of those terms correct without even stumbling on them. But that one is isolated. That is a deposit. Actually, this has two deposits in it. And no, as long as I'm careful not to start on the blue protective bouncy wall of zeros around it. The reason I call it a bouncy wall is my metaphor for this is, you know, those inflatable castles and stuff. Or maybe the inflatable wrestling ring they have for kids' birthday parties. It's not just a flat surface of inflated rubber balloons. Otherwise, kids would be falling off the edges every which direction with broken arms and everything, and the parents of the birthday boy would get sued for all they're worth. No, they all have those bouncy walls, so that if one kid throws another kid at the wall, they just bounce off and stay inside. That's what's going on here. If we go off the edge, we bounce off the wall and come back immediately. Look where we are now. We haven't solved the problem. We haven't even gotten close. What we've done is get rid of a lot of the ugly technical details so we can concentrate on what we're here for, which is recursion, for crying out loud. But look at the problem. We started this. This was the input file. We're not changing the file. We read this in, and we get to store this any way we want. We choose to store it this way. Because each one of these little pockets here, each one of these squares, either tells us yes or no whether it has oil, being a 0 or 1, and it keeps us from going off the edge. We bounce into the wall and come back when we hit a base case. That's the starting point. We're not even really started yet. And I am going to remember this time to say, see you online.